The plane of the figure represents a horizontal plane. A thin rigid rod at rest is pivoted without friction about a fixed vertical axis passing through point O. Its mass moment of inertia is equal to 0.1 kg centimeter square about O. A point mass of 0.001 kg hits it normally at 200 centimeters per second at the location shown and sticks to it. Immediately after the impact, the angular velocity of the rod is. So we have to find out the angular velocity of the rod after the impact in radians per second. Let's look at the solution. We are given with the mass moment of inertia of the rod about point O, which is 0.1 kg centimeter square. We know the value of point mass, which is m is equal to 0.001 kg. It is given that the velocity with which the point mass hits the rod is v is equal to 200 centimeters per second. Since the point mass hits the rod normally, that is perpendicularly, and sticks to it, the rod and the point mass can be considered as a system at that instant of time. Then, using the principle of conservation of angular momentum of the system, initial angular momentum should be equal to the final angular momentum. That is, m into v into r should be equal to the moment of inertia of the system about point O multiplied by the angular velocity. The left hand side remains the same, which is m into v into r, and since the system considered is both the thin rigid rod and the point mass together, the moment of inertia about the point O is the moment of inertia of the rod plus the moment of inertia of the mass about point O multiplied by the angular velocity. Now, substituting the corresponding values, in this equation the only unknown is the angular velocity of the rod after the impact. Upon simplification, we get the value of omega as 10 radians per second. The accepted answer range for this question is 10 to 10.